Before we run the demo, we need to make sure the SOC Simulator tool is properly installed. So we can get it from GitHub and then unzip the downloaded file. And then we have a configuration to create from the template. So we can copy the template to a local configuration file and then modify just the IP and to match the local instance. You can use the sed or a text editor if you want. Now we are ready to run the to launch the demo script. The scenario we use today is alert enrichment, triage, and remediation. To run it, we use the tool, and then we provide the path of the scenario. Alert. All right. So the alert. This scenario is composed of two sections, or two, let's say, sub-scenarios, if you will. One of them covers a remote exploit, and the second one is about a VPN connection from abroad. So the first one is a remote exploit where a specific CVE is used, specific vulnerability is used. And what FortiSOAR does is to check whether the targeted asset is vulnerable to this CVE. If it is, especially if the alert comes from an IDS or an IPS configured in monitor mode, obviously the attack is most likely successful, so the alert will be escalated into an incident. If the used CVE doesn't exist or is not, if the target asset is not vulnerable to this CVE, so automatically the alert will be closed as a false positive, and the analyst doesn't need to spend any time on it. Okay, so now let's have a look at the first alert. The alert comes, it will be parsed, and then we have in the workspace comment section here, we have all the different steps that the alert or the investigation, the automated investigation performs. So starting by fetching vulnerability data about the asset, parsing the different fields, finding out which MITRE technique ID is relevant to this particular kind of attacks, extracting all the different attributes, indicators, assets, users, etc. And then, of course, the indicators will be rated by a CTI, so Cyber Threat Intelligence. We have here Alien Vault, we have Virus Total, OpSWAT, and you can see the reputation from these different CTIs right in the comment section. So for this particular attack, we can check that the source IP is malicious, so most likely, well, this increased the criticality of the alert, but most importantly, and this is the main reason why the alert has been escalated into an incident, is because the used CVE on this target, on this asset, so 0.67, is actually part of the vulnerabilities that the asset has. So you can see here the reason of the escalation, the asset is vulnerable to the CVE. We can double check that by going to the correlation tab and then asset, and then we can open the asset and find the vulnerability right here. Now, this asset has been enriched from the vulnerability management system. So we get the operating system, we get the name, the NetBIOS name of the device, we get the MAC address, and other attributes. We can check the enrichment playbook or the enrichment automation workflow right here. So it connects to the, in this case it's Tenable, so it connects to it and it fetches the required information, of course, along with the vulnerabilities of this particular asset. So to summarize, attack happened using specific CVE. The asset is vulnerable to that CVE, which means that the attack is most likely successful. This has been escalated into an incident that we can see right here. So the incident has been created with the same parameters like the alert, and it has been, the description has been enriched with data from the linked MITRE attack technique. right? So we have all these vulnerabilities of the asset, the source IP address. We can actually increase the correlation view to see exactly what happened. So we have this attacker using this specific vulnerability against this specific asset. All right, and then so then we can go to the second alert. So the second alert is also a remote exploit, but in this case the used CVE is very old, so from 2008. So the asset is not vulnerable to it. So the analyst doesn't need to spend any time on it. The asset, as you can see, is closed automatically, and then we have a closure note which says that the system is not vulnerable to this CVE, so there is no need to spend any time on it. All right, the second part of the demo covers this remote connection. So it's a VPN connection from abroad. And in this VPN connections, one of the users is allowed to from that specific location. So we do enrichment with WHOIS to identify what's the geographical location from where the connection came. And based on that, along with another enrichment from Active Directory to understand whether that specific user is allowed to connect from that area or not. So based on that, of course, if the user is allowed, we close the alert as a false positive. And if not, this is most likely credential theft, which means that the credentials of the user have been stolen. Let's have a look at the alerts. So the first alert is still being processed. It's about the user Ricardo. As you can see, the alert has been closed automatically, and FortiSOAR automatically asks to close the alert on FortiSIM if needed. Of course, we can disable this feature if it's not required. So we can see here that this is the source IP. This is the user or Ricardo, which connected to the environment. The most important information here is about the user. So we can see that we have an enrichment that happens via Active Directory. So we get the security ID of the user, the different groups that the user belongs to, the domain, of course, the primary group, etc. And the information, the most valuable information in this case is the groups. So we see that the user belongs to the group Japan remote branch. So what FortiSOAR does, it checks so it does the enrichment, of course, on the indicator, and it detects what's the source country where the connection comes from, and it compares the source country to the groups that the user belong to. In this case, the user is part of that group, so this connection is legitimate. Therefore, it's closed automatically. As you can see here, per the closure note, the user is allowed to connect from that remote location. Now, let's check the other alert. In this alert, we have many indicators. So one of them, the indicator is malicious to start with. That's one. Second, the user Jill is not allowed. So if we see the user metadata or the user information, you can see that the user doesn't belong to the US. The connection is coming from the US, but it's malicious. But then we have another clue which indicates that this is an actual credential theft because the connection is successful. Is the user is not allowed to connect from that particular location. Therefore, the alert has been escalated into an incident, as we can see right here. So we go to the incident, and at this point, we can trigger a remediation right away by triggering the credential theft remediation playbook. So we click on the playbook, and we can track the execution of the playbook in the playbook tab, and we can do so as well from the playbook logs right here. So the playbook is requesting an approval to perform the remediation actions. So we'll go ahead and approve the remediation. So it's clearly stated that the remediation is to block the source IP address and disable the stolen credentials from Active Directory. We will click approve, confirm, and then we can track back the playbook execution. And as you can see, the source IP has been blocked on FortiGate, and the user has been successfully been disabled from Active Directory. One more thing to show here from the reporting perspective is the report for each incident. So we have an incident report that we can generate by clicking on this button right here. This will trigger a playbook which will generate the customized report for this specific playbook. So we can go to reports, and we can find the previously generated reports right here. Then we can download them, and we can check it out on, it's a PDF file. So we can, for example, send it by email or even schedule it if required. And that's about it.